they have exactly same. This is a 7 strand. This is 7 strand. 1, 2, 3. Yeah, 6 plus center one. Normally in these steel ones, you will see the center one is slightly bigger. Center wire is slightly bigger, and then they wind it at a pitch of about 12 inches, about 300 millimeters. So, and take a look, and then you can see the difference in weight. That's why I have individual wires. Okay, so now S glass, E glass, like we already talked about, different kinds of glasses. Now we can just, if you don't mind. So even that one. Yeah. Okay. Yeah. Perfect. So actually, if you make the room very dark, you'll feel sleepy. So that's not a good idea. Of course, sometimes it's a good idea. If the presentation is boring, I mean, better sleep, Why? Okay. So S glass, S2 glass, they're a little bit more expensive, high strength. They have more strength. $5 is a little bit high, like 350 to 400 rupees per kilogram, which is slightly higher than other one. And there are some good characteristics and some bad, not so good characteristics. So, like in anything in life, you want better mechanical properties or better characteristics, you have to pay more, right? That's life. So, and then we have, for single fiber, the strength is very, very high, but in composite form, that strength will not be the same. The reason for that is there can be a lot of fiber breaking, and then you also have matrix, right? So we will lose some strength. So I'll just move forward with this quickly so we don't spend too much time on. They're all self-explanatory. I will let you read it. You can get glass fiber in many different forms, just like I have here. You can get rovings, oven, like oven means like almost a weave. Mats, this is a mat, this can be a mat, this is a mat. And you can combine the products, cloth and fabric, this is fabric. Fabric works very well for wrapping. I have done a lot of tests with these basalt fabric, works very, very well. Okay, so there was a question, I think, I don't remember, somebody asked yesterday, how do we maintain the alignment? This is what you do. So sometimes you have the primary fiber in one direction and maybe a cheaper fiber in the other direction. Okay, that way you can define the stronger direction, particularly for wraps. You would want stronger direction to be in the circumferential direction. Okay, so all right. We'll just move on. Carbon fibers, we have different kinds of carbons. High modulus is one thing that really is helpful for carbon fibers. We have very high modulus. That's the reason they use this carbon fiber in aerospace industry. I'm just flipping the slides because most of them we already talked about these items already. In toes, you will have, in each toe, you may have hundreds of thousands of fibers. Pre-preg, does anyone remember what a pre-preg is? Yeah, it's like, see the ready-made meals you get in supermarkets, you bring them home, heat it and eat it. It's like that. So you pre-preg is, you make the composite, keep ready, everything is ready, you just do whatever the instructions tell you to do. So, and then carbon fiber, again we have many different types. Like I said, as civil engineers and structural engineers, we are not really going to design these ourselves, the actual fiber and fiber matrix combinations, we won't. But at the same time, if if you are in charge of a project or something, it's always good to know what to ask your fiber or the composite supplier. Sometimes they tend to take advantage of your ignorance. Sorry, nothing about, nothing, you didn't hear that, okay? So carbon is very expensive. Carbon is slightly expensive, which is $20 per kilogram. It's about whatever that is, about 1,500 rupees, let's say. And aramid, like it was pointed out, it absorbs a lot of water. That's a big problem. But at the same time, it is very useful in energy absorption. So basalt actually was a Russian product. This one here, Russia, Ukraine, they were together at some point, right? Now they are fighting every day. But this is a Russian product or former USSR product. They used to make bulletproof vests with basalt fabric. Okay, so it's very good for that kind of ballistic applications. If you want to use it in defense applications, I know some of you have contracts with defense industry. So for ballistic applications, these are very good, good product. Then they started opening up their market to the Western world, and that's when they started selling or at least showing that these are the products they use for their ballistic applications. Now there is a lot of consumption of basalt fiber, particularly in some of the auto industry like Toyota and other Japanese cars. They use basalt fabric as a liner in the engine because it is very high temperature resistant. Say that again. Weight very less. Yeah, weight is also less. That's true, but more than that, it's the high temperature resistance which is attractive. Otherwise, if it is just weight, then you can use glass also, right? But you cannot. Glass will just melt and it will not work under very high temperature applications. Okay, so like some of our colleagues here in this room highlighted that problem, it absorbs a lot of moisture. That's a big problem. I personally have not played with aramid fibers, so I cannot give you first-hand knowledge of this, but there are a lot of professors in this room who are working with aramid fibers. Okay. All right. You want to say something? No, go ahead, please.
Default is like invented Kevlar.
These companies are buying each other, so nobody knows. Today they are called Kevlar, tomorrow something else. I don't know. China is actually, I mean, I don't want to like offend anybody, but China is able to reverse engineer everything, and they are making basalt fiber and Kevlar fiber, everything. Everything is discovered or they are invented in other countries. They take the product, go back, do the reverse engineering, and they make the product so cheap that the main company who has actually created that new product will go out of business within no time. So what can we do? We can't do much. So this is a new one. That's the reason I mentioned that. All right. In Kevlar also there are many different grades. We'll just move on. So basalt fiber is something very close to my heart because I've been working on this basalt fiber for more than 15, 18 years. Now I'm giving out my age. So anyway, so this is basalt is from basalt rock. Okay, it's just solid rock. So they melt it, make basalt fiber, and then you can make bars, mesh, this kind of ties. They have come up with this idea of using U-shaped ends. That's for bar ends. So you add lap length to your straight bar, and it's a little bit of duplication, but still you can achieve better development lengths using this kind of special designs, I would say. Look at this. He's from Norway. The guy who used to write my checks. So imagine he's picking up the whole cage with one hand. Of course, he's breathing hard. Okay, but still he's able to lift it up, right? So it's so light. Can you imagine doing this with steel? No way. No way. Yeah. This is at least my sponsor was from Norway. Yeah. Then you have coils of this basalt material. This is from China. Now they are able to flood the market with basalt. Unfortunately, they are not able to sell much because there is a lot of problem with basalt bars. The alkali environment, they are really not doing very well. So basalt bars are struggling because of that. Then you have different surface preparation, fiber wound around the bars, and then plain bars, braided bars with sanded coat. This one is a good example of sanded surface, right? You want to add anything? How do you make this? You make this, or you are selling this? You are only selling it. You're manufacturing. How do you sand this? Can you speak loud so everyone can hear?
When pultrusion are going,
Yeah.
then
You spray.
fibers are going with bathing with resin,
Right.
and then
Can you
sand coating.
speak loud? They may not be able to hear you.
Whenever pultrusion are the machine called pultrusion.
Okay, go ahead. Sorry.
Whenever pultrusion, it is called pultrusion.
Yes, that's right. I'm going to present that position. Yeah.
Whenever fibers are going through the
That.
bathing with resin,
Yeah.
then sand coating are there, and after that curing is there.
Okay, so these bars, I'll show you pultrusion method very soon. Next slide, next set of slides. So when they're actually pultruding this, they spray the sand and it becomes very messy. That's the reason that generally these days. And the sanded surface is not as effective as the other surfaces like this one here. This is definitely better than this. Okay, so and this one here, are you making the grooves?
Yeah, fibers.
Oh, it's a spiral wound fiber. Okay, great.
This is Gujarat.
In Gujarat. Do you have any specifications for that?
Yeah, I have in catalog.
Okay, good. Yeah, we'll go through that in a minute. Okay. Perfect. So, actually, these are the common basalt bars. Now they have moved to mini bar concept. Actually, mini bar concept was developed by my collaborators and me. We did the initial development for this. It works very well, actually. It's a little bit expensive, but like I said, for good things you have to pay more. Okay, okay. This one here is a machine they designed to make mesh, or not mesh, but nets. So you can have two-dimensional net, and this head will travel in this direction. It can travel in this direction. So that's how they actually feed the fiber already wet, which is already wetted with epoxy, and place it, and then it will cure in a day or two. Okay, so we are still catching up from yesterday's presentation. So if you think I'm going too fast, please slow me down. Or if you are happy to be done, then just let me go faster. Okay. Okay, now we will look at glass fiber production. Interesting. So this is all production of glass fiber. So how do you make actually basalt also is made this way, very similar to this. So this publication is by PPG Industries, that's Thomas Bohr and Bob Locovaral. You will not find this anywhere. Somehow I found this and I'm giving him credit here, so it's not my material, but it's very useful material. So how is it done? Manufacturing glass fiber. So here we are looking at making the fiber which is of this form, very, very thin fiber, just like your hair. So how do you make the fiber? So this is an industrial scale production flow chart, so to speak. There are a lot of silos here, right? You have silos for clays, limestone, silica sand. Those are all raw materials for glass production. Boric acid and fluorospar. Okay, so different silos. They're not all the same. Like the quantities differ. Some of them are just additives. Some of them are primary constituents. So these are all weight batched automatically. You put it in the funnel here, and then you blender, and then you put it in the surge bin and feed it into the furnace. This is the most important part of the process. You actually melt it to flow. So this is molten material with proper ingredients, of course, and then it's made to pass through a platinum bushing. So it's platinum bushing is it's a plate with many fine diameter holes. Okay, very small diameter holes, thousands of them. So that liquid is passed through those platinum bushing holes, and then it is taken up. What I mean by taken up means it's spooling it here. So the fiber it forms into filament here. You apply the binder application. Another name of binder application is thank you. Another the sizing is the coating on the surface of the fiber. Remember that. Sizing is what it's called. The coating on the fiber. So they apply the coating and then they spool it. So just to get a feel for how big these silos are, that's how big they are. Huge silos. Okay. So one may have silica, sand, may have clay, something else may have some other material. And the next phase is to put it in the furnace. And furnace here, raw materials are melted in furnace. 2800 F is how many degrees centigrade? About 1500 maybe. Okay. So 1500 degrees centigrade, that's how much it is working at. That's the operating temperature. And it's conditioned for uniform temperature and viscosity and stuff like that. Molten glass flows through gravity, by gravity, to the floor hearth, which contains the fiber forming area in the underside. So this is what it looks like. It's very high heat absorbing process. Not good for sustainability, but that's something you need. Very high temperature. So this slide is not clear, but this half of the slide is front view. This half of the slide is side view. Okay. So the fiber is extracted. The fiber is extracted. It's more or less called like a pultrusion. It's extracted and then bundled and it's spooled. Okay. So if you see from the side, this is what you will see. That's the spool. It's coming through here. And remember, what was the temperature here? almost 1500 degrees. Yes, centigrade, right? What's the temperature here? Almost room temperature. So in a short length of about couple of meters, less than couple of meters, it's going from 1500 to almost room temperature, about 25 or 30 degrees. That's the challenge to this process. So you and I cannot get a small furnace and make these fibers. We cannot, because this is the process. Otherwise you cannot, if it is too fast, all the fibers will break. If it is too slow, fibers won't form, right? It's a very tricky process. So they spray water to reduce the temperature from 1500 to room temperature, and then they spool it. So when you are spooling it, there's a lot of water with the fiber, right? Because you're wetting it here, you're spraying water to cool down the fibers. So that can be a problem. This is what a bushing looks like. Okay, hundreds and hundreds of or thousands of holes. And platinum is, I don't know if you know platinum, but it's more expensive than gold. Okay, but no one wears platinum jewelry for some reason, I don't know. But so anyway, so it's very, very expensive metal. And then these bushings have to be changed every time or every few cycles. So the total cost or large part of the cost of the production of glass fiber is right here. Two items. One is heating and the other one is platinum bushing. So these are the two items. If you are, see, young people have to always think in terms of starting your own business, okay? It's very important for you start very early in your life. There can be some failures, but if you want to really be something, start a business. So if you are trying to start a business, this is what you are looking at. Where is the money going? So platinum bushings. So what we have done with our group in Norway, we tried to replace this platinum bushings with ceramic bushings. They last way longer than platinum bushing, and we found that it was cheaper. But unfortunately, by the time everything was sorted out, the guy went bankrupt. So that's dead. Okay. So now those are the forming winders. They just take up all the fiber, and then they are different depending on what your end application is. They spool it in different ways. So they have textile bobbins and then roving packages, different kind of thing. Sizing is this is the sizing tank. So these are, it's actually